Hey guys, in this tutorial, you're going to learn how to create the backend infrastructure for a recipe app. This is basically going to be a CRUD application where you can create get, post, put, and delete requests. For example, users will be able to create recipes, search for recipes based on some filtering criteria ranging from ingredients, authors, or anything regarding the informations of those recipes. So there will be this searching capability added to this application. Other than that, users will be able to get specific recipes based on their IDs or any unique number dedicated to these recipes. They will also be able to rate them and attribute a certain point to these recipes, and they can finally comment on each recipe. We will also create APIs to generate users. Every user will be able to have access to their own profile and update their information. For every single user, we will create these mechanisms through which they can follow other users. We will create three groups of API endpoints. The first group is authentication. We will use JSON Web Tokens to create secure APIs so that unauthorized users will not be able to have access to our endpoints. The second group is related to users themselves. So the admin will be able to have access to all users and create new users and update their profile along with following particular users. The third group is related to recipes. So the users will be able to create recipes, search for certain recipes based on those filters, and they will also be able to delete particular recipes based on their unique identifier or their unique ID. They will also be able to rate those recipes and comment on them. We will use Node.js and MongoDB as our main tech stack for this project. So you are highly recommended to download MongoDB from its main resource and choose your platform, whether you're working with macOS or Windows or Linux. Try to select the one accordingly. And you're also highly recommended to install Compass, which is a graphical user interface for MongoDB. It will give you this kind of flexibility to see what's happening on your database, what kind of data is being saved, and how you can delete some data. So it can give you lots of flexibility in that regard. Since our API endpoints are categorized into three main groups, we will follow the same logic here as well for routes and controllers. We will have three types of routes: users, authentications, and recipe, each representing their own category of APIs. And for controllers also, we will have three separate files, each in charge of dealing with business logic, with authentication, recipe creation, and user-related functions. So everything is perfectly separated, and this will also help us scale this application down the road, so everything will be dismantled right from the beginning. We'll configure the database inside the config file, and we will define the JSON Web Token middleware inside the middleware folder. We will also define two types of model, each representing the user model and the recipe model. So basically they are the schema, the general structure of how users and recipes should look like what kind of keys and properties they need to have in order for us to have a very understandable and scalable data model. So let's dive into the code. First of all, I'm going to create a server.js file here. We're going to use Express.js, so I'm going to go ahead and install Express.js along with some middleware. Body parser, course, and .env. Body parser is particularly useful to load and parse your JSON and URL encoded data. It allows you to handle data sent in HTTP requests. Other than that, we have CORS here, which stands for Cross-Origin Resource Sharing. It is a security feature, and it enables your application to specify which domains are permitted to access your resources. You can feel free to read more online about this specific middleware. The last one is .env, which allows us to use the env file, which is a good way to restore sensitive information like API keys. I'm going to go ahead and install all of them here. Let's create the server file. I'm going to start with Express. We had already installed it, so all I have to do is to require it. Next, I'm going to add the middleware. Let's start with the body parser. And continue with CORS. And let's include the .env. Let's start the application here. I'm going to call it app. It's going to be an Express app. And next I'm going to add the middleware. To use the middleware, you can use the term use here. Let's start with the CORS first and move forward with the body parser. And we're looking for the JSON file. Next thing, I'm going to define the port. And this is going to be imported from the .env file. So we just write it down here and then create the env file. Later on, we're going to define the port as port. And I'm going to add the default value like 5000 here. So let's just define that .env file here. And let's define port as 5000. Once again, the .env file is used to secure and store the sensitive information like API keys or port numbers or anything sensitive. So back to the main app, we need to run the .env file in order to have access to anything stored on the env file. So I'm going to go ahead and configure it. And let's write last part. Our app is supposed to listen to this port. And there's going to be a callback function here. Something as simple as this log message. Server is listening to port whatever that comes from this value, port value. You might have noticed that my codes are being automatically reformatted. That's because I'm using Prettier, which is an extension for VS Code. So you're highly recommended to use it. You can get it from the extension here. So Prettier is a good code formatter. Make sure to use it. Other than that, since I have already used the port 5000, it is occupied, so I'm about to change it to a different number. So you can feel free to change it if you had already used port 5000. Doesn't matter. Let's run the app. So it is listening to port 5001. Next, I'm going to define the database file. So let's add a folder and call it config. Inside config, we're going to have the db.js file, which is a way to get connected to MongoDB. We're going to use Mongoose. Mongoose is an object data modeling ODM library for MongoDB and Node.js. It provides a schema-based solution to model application data. Let's import it. Next, I'm going to define a function to connect to MongoDB. Let's call it connectDB, which is an asynchronous function. And we're going to have a try catch block here. Inside the try block, we'll define the logic required to get connected to MongoDB. So the first part is where we define the URL. As you can see, this is part of the environment variables. So I need to define Mongo URI, that URL required to get connected to the database. And then I'm going to add the structure. You don't really need to memorize this kind of a structure because it comes with the Mongoose documentation. Use new URL parser. Let's define it true. And use unified topology is another key here. Once Mongoose gets connected, we would like to have a message. So I'm going to log this message. MongoDB connected. And inside the error block, we would like to console an error message. DB connection failed. And we can log the message here. I'm going to add the process.exit. This line terminates the Node.js process with an exit code of 1, indicating that the process exited due to an error. If the connection to the MongoDB database fails, the application may not be able to function properly. So calling process.exit1 ensures that the application terminates immediately, preventing it from running in an unstable state. Let's export it. Let's not forget to import the Mongo URI from the environment variables. And of course, we need to define it first. So I'm going to add Mongo URI to the environment variables and set it to a default value, which comes from the MongoDB database. I'm going to bring the Mongo URI from the MongoDB Compass. So if you open the application MongoDB Compass on your computer, you can have access to this URI. I'm going to copy it and paste it here. We would like to attribute a name to our database, so it will be easily distinguishable from all the other tables and databases inside MongoDB. So I'm going to call it Backend Recipe. I'm going to save it. Let's get back to our database setting. As you can see, Mongo URI is not properly imported, so we need to do the exact same thing which we did on the server. So we're going to use the .env and we will use the config here. I'm going to save it. In the server, we need to somehow import this database. So I'm going to define a new constant here and bring it from the config file or the config folder and database. Let's save it and let's call it connectdb. So once our server starts to run, this function will start to be called, and we would normally expect to see that MongoDB is connected. So I'm going to restart the server from here. npm start. Okay, there's an error. Let's see what it is. So it cannot find module mongoose. We kind of forgot to install it. So I'm going to go ahead and npm install mongoose. Okay. Let's run it again. npm start. Okay. Now it is connected. You can see these messages. Service is listening to port 5001 and MongoDB connected. The next step is to create the authentication routes for signing up and logging in. So I'm going to go ahead and create our first route. This is going to be like a middleware. So let's define this API auth and let's call it auth routes. Needless to say, we need to define it. I'm going to create a folder here. Inside routes, we will have this auth routes. Let's import the express here. And require the router. Let's create the first endpoint, which is going to be a post request for signing up the users. So I'm going to define it as a post request. And once a user goes through this URL ending with signing up, they will use a particular controller, which we will define later on. So let's call that controller sign up. And let's export it. Back to the server file. We need to define this auth routes or import it from this file. I'm going to define it and require it from the routes. Save it. Now that we have created our first route, all we need to do is to define the sign up controller or sign up function through which users will be able to sign up. But prior to that, let's just organize these imports and require files. So I'm going to put this route here and separate all the requires from functions that have been called here. So it doesn't make any difference, just to make it more readable. I'm going to go ahead and define our first controller. Let's create a folder and call it controllers. Inside controllers, we'll have the logic function. So let's call this controller. And let's just create a hypothetical function to see if it works. I'm just going to log a message. Console log. Sign up works. Let's save it. And I'm going to use Postman to test this. So to have a quick recap, we want to have the users go through this API auth / sign up and then have this sign up function working for them. So this route is supposed to be a post request, which triggers this sign up function. Now that we have defined this sign up function as a simple log message, we need to import it inside the auth route. I'm going to head back to the auth route. So going to type sign up again, and I can see that it can be automatically imported from the auth controller. I'm going to save it. Let's open the Postman. If you haven't already installed Postman, you're highly recommended to go to the postman.com and download the application based on your operating system. I have already installed it. Once you open the Postman, you can create a new collection. So you can call it whatever you want. Since I have already added this kind of collection, I'm gonna go ahead and test our first endpoint. So this is going to be a post request, so you need to select the post. It automatically selects the GET request, so make sure to select the proper requests. Since I'm running this application on port 5001, I am using port 5001 here. So the URL is localhost 5001, API auth signup. Let's run this. I'm sending a post request, but before that, I need to run the server. Okay, server is listening to port 5001 and MongoDB is connected. Let's run this post request. And as you can see, we have this log message appearing here. Sign up works, meaning that this has gone all the way from this route to the controller, and the controller is logging this message. Once again, this is a hypothetical function, and this is not a proper way to handle post requests. We need to define a request response mechanism within an asynchronous function in order to properly handle it. So I'm going to edit it right now. So first of all, I'm going to turn it into an asynchronous function. So let me add the async term here, and this is going to have a request and a respond parameter here. Let's remove this. We need to take 5 steps to create the signup function. First of all, we need to get the user's credential, which includes the username, the password, and the email. And then we need to hash the password, because we don't need to have the exact password to be saved on our database. From a security perspective, it's important to convolute that exact password into some weird alphanumeric character, which is not easily decipherable. And the third step is to create an instance of that user or that user schema, which I will explain down the road. And the next step is to save that user instance, and finally to send a successful message from the server. Let's get the username, email, and password. They're going to come from the request body. We'll use bcrypt library to hash the password. So I'm going to install it. Once installed, we need to import it. So I'm going to hash that password and call it hashed password. In case you're wondering what this number 10 is, it's actually a cost factor, which is here used to make it computationally expensive for attackers to brute force or guess the hashed values. Even if they have access to the exact hash value, it would be almost impossible to turn it into the real value and be able to enter our website or use our endpoint. So it's important to use this number. And you might wonder why not using a bigger number. There's a fine line between using a smaller number or a larger number, and if you increase it to a larger value, you are just trading off the performance of your application. So something between 10 to 12 would be a standard number. The next step is to create an instance of the user's schema. So first of all, we need to create that schema, that general structure which represents our users, and then create an instance out of it. This is how the user schema is supposed to look like. We're going to have an object including properties like username, password, email, and followings. And followings will have an array of values referring to usernames or people that are being followed by a particular user, like user A follows user B, C, and D. I'm going to give you an example of an array containing a lot of different users. As you can see, in this array, which is an array of multiple values, let's say there are hundreds, if not thousands of users, every single object here would represent one. For instance, the first one, username boy, with a particular password, an email, and a list of following, which are some hashed values. As you can see, there are two specific properties here that we didn't already include: the ID and the or the version. So these are being automatically added by MongoDB, and the ID would be something unique representing the uniqueness of every single JSON object here or the user. Let's not forget that the passwords will be hashed, so these values like 1, 2, 3, 4 will not necessarily appear here. So you will see something like this value, 6, 7, 5, 8, whatever it is. So it's going to be convoluted into an undecipherable value. Let's create a new folder and call it models, and then add the user schema there. We need to have mongoose. And we need to call it user schema. Doesn't matter, but it's a convention in naming the schemas. And this is going to be coming from the mongoose. Now let's focus on those keys, the properties that are supposed to be part of our schema. So first of all, we need to have usernames. We also need to have emails, password, and followings, referring to users that are being followed by particular users. Now, let's attribute some features to every single key here. For example, let's define that what their type is, or whether they are required to be entered by the user, or decide whether they are supposed to be unique or not. So I'm going to define them here. So this is going to be string. Usernames are supposed to be string. They are going to be required, so it's going to be true, and there need to be unique, so their uniqueness must also be true. This is exactly the same for emails. The emails are supposed to be type string. They are required, and they're supposed to be unique. For the password, it's going to be a little bit different. It's not necessarily supposed to be unique. Maybe two people enter the same password. So I'm going to remove the uniqueness of the password. For the followings, it needs to be an array of various values. So let's define the type. We are going to refer to the exact same structure of the user. Like the user will have an ID, which is going to be automatically added by MongoDB, and all we need to do is to have access to those IDs or object IDs. So I'm going to do this. I'm going to say, well, go through the schema, go through the types, and look for object IDs. we might have tons of different schema in our project, but we are specifically looking for the user. So it needs to refer to the user schema. Now we need to export it. It's going to be model, call it user, and user is corresponding with user schema. Just saved it. And now I'm going to use this inside our controller. Let's import the user schema. Inside the models. And it was called user. I'm going to create an instance, the user. It's going to have access to the username, or it's going to be populated by the username, which is entered by the user. It's going to have access to the email. It will be filled out with the email. Last but not least, the password. Once again, this is not going to be the direct password being used by the user, but it's about to use that convoluted value, that hashed value, which we already called it hashed password. I'm going to save it. Let's save the instance. And let's respond it. It's going to have the status code 201, meaning that it has successfully created something, and it was a post request. And we need to have a message here indicating that, well, it was a successful message, or user created successfully. It is important to have a proper error handling mechanism, so it's better to put everything here inside a try-catch block. So could have done it already, but let's just do it here. Gotta cut everything here, paste it there, save it, and inside the error block, I'm going to use status code 500, indicating that there is a server-related error. Let's run the server and see what it does. I'm going to test it on Postman. Okay, server is successfully listening to port 5001. Database is connected. So here we are, creating a post request. We need to have a particular body consisting of username. Let's call it password. I'm going to call it 1, 2, 3, 4, 5. An email. Let's call it boy123@gmail.com. And I'm going to send this post request. Okay, we've got this message, user created successfully. So the server has gone through this controller. It has accessed those three values from the user's input, username, email, and password, hashed the password successfully, created an instance of that user schema, and then saved it on the database. And the response was something like this: user created successfully. Now we need to see it in action. We need to open the database, the MongoDB Compass, and see exactly what's being created. Let's open MongoDB Compass here. Okay, I'm going to maximize it so you can see everything. Let's click on connect. And here we go. We've got this backend recipe. The user's model has been successfully added here. There are four main keys: username, email, and password. You can see the password has been hashed successfully. So instead of 1, 2, 3, 4, we've got this convoluted value. The following is an empty array, and there are two values, ID and version, that have been successfully added. The next step is to create the logging function, a system through which users will be authenticated to take certain action. For example, creating recipes or follow other users and do certain things that unauthorized users will not be able to do so. Let's create the logging function inside the auth controller. We're going to call it login. It's supposed to be an asynchronous function. Let's use a try catch block here. We need to have access to credentials entered by the user. So emails and password are what we're looking for, which comes from the body of the request. So assuming that it is the correct email, we need to find it from our database, from MongoDB. So there is a certain user with that certain email. We're going to use the method find_one, which looks for that certain user. So once the user is found, we need to compare passwords. So I'm going to put a conditional statement here saying that if the user is not found, or if those two passwords do not match, send an error. We're going to use the compare method in bcrypt and compare the plain text password entered by the user with the one that we've got from this user, which is an instance of the user schema. So I would like to draw your attention to this part. This is not the plain text password. This is that convoluted value, that hashed password, and this bcrypt will compare those two values. If there is a match, then this statement would be true. Otherwise, it would be false, saying that those two passwords do not match, or in other words, the user has entered a wrong password. So in case there is no match, we're going to send a status code 401 with JSON message saying that credentials are not correct. Now let's assume that the user is found, the email is correct, and the password has been entered correctly. So this if statement will not come into play. Now we need to create a token using JSON Web Token. Let's install it first. Okay, now we need to require it. Call it JWT. Save it. We need to use the sign method in JWT. So we're going to create a token using the sign method. The sign method takes three parameters. The first one is the value that we need to tokenize or we need to sign. It can be anything regarding the user. It can be an ID or any sort of information. In this case, we're going to use the ID coming from the user instance. You remember that MongoDB automatically attributes this -id, which is an identifier for every instance. So we're going to use it to identify the user trying to log in. The second parameter would be a secret, a JWT secret, something to tokenize, something to create this convoluted value which cannot be easily deciphered by attackers. So I'm going to use it here and call it JWT secret. And we need to import it from the environment variables from here. So let's use the process.env.jwt. I'm going to copy this and put it inside the env file. Make it as long as possible. The point is to make it complex for the attacker to decipher it. I'm going to save it. To be able to use the environment variable, we need to bring them on here. So let's call it .env. Let's configure it. If you don't add these two lines, you will not be able to have access to those environment variables. So it's crucially important to put them first. The third parameter for sign method is to set an option to expire the token. We do not want to have a permanent token. It needs to expire within a certain period of time. So let's expire it within 1 hour. So basically, we are creating a token, convoluted value, which contains the ID of the user that tries to log in successfully. This token will expire in 1 hour. So after 1 hour, this person will not be able to have access to our endpoint. So once the token is created, we need to send it as a response. Save it. Now let's complete the error block. It's the same as the previous one. It's going to respond with a status code 500 telling that there is a server error. To have a quick recap about the logic, I'm going to draw your attention to what's happening here. We're trying to have access to the email and password, the body of the request. So once the user enters the email and password, first we just try to find if there is any instance of the user schema based on that email. If there is a user, we're trying to find if the password entered by the user matches the hashed value within that user schema. If neither of them are found, then we will send an error here telling that it's a wrong credential, whether the password or the email is wrong. So assuming that the user is entering the information correctly, we create a token using JWT. The token takes three parameters. The first one is the ID coming from the instance. So every single user has got a unique ID. The second parameter was a secret key, some long string of data, which helps us to tokenize this value or make it like a hashed value. And the third option was the time that it would take that token to be expired. So we set it to 1 hour, meaning that it will expire. It will be totally useless after 1 hour. So the user will not be able to log in or have access to any of the other endpoints. Once the user has created a token successfully, that token will be the response of this controller. Let's go ahead and test it out. First, I'm going to run this app. Then I'm going to open Postman. Okay. This was the previous one. That's sign up. So let's just save it and move on. Let me just rename it so it will be easily distinguishable from now on. I'm going to call it sign up. We're going to create a new one. New requests. This also is a post request. Very similar to the previous one. I'm going to copy that previous URL and slightly change it. Once again, don't forget that this comes from server, API, auth, and then it goes to auth route. There is no there is no login, so we need to create it. And let's call it login. Remember that the name of this function was login, so I'm going to import it. Once I type login, it automatically brings the route, so I'm going to save it. API auth login. Back to Postman, API auth login. We need to create a body. Remember, the body tries to have access to the email and password. I'm going to use the exact email and password coming from the sign up. Just copy this. This is the body of the sign up. I use it. Username was not required, only email and password. The order doesn't matter, but this is for convenience. Let's make sure that the server is running. Okay, it is connected and running. I'm going to send this. And here we go. If you send this on the body, you will see the token is created. So this is the result of this auth controller. I created this logging and we entered the correct email and password. The token was created. The token is a weird value, a long value, which was the result of this signed message. It's going to expire in 1 hour, and that was the result of this response. Let's assume that user enters something incorrectly. Let's say the password is different and it doesn't match with the value provided from the sign up controller. So I'm going to add a bunch of other characters here. Let's send it again and see what happens. Okay, so that was a wrong password and this message was triggered because even though the user was found, the email was correct, so this part of the if statement was not triggered. There was a user. However, once bcrypt tried to compare those two values, the plain text password, this one, with the hashed value, which is already stored on the user instance, it couldn't find it, so this was false, and this response was the result. Let's just get back the previous token. I'm going to log in again. We're going to use this token for future endpoints because if the user does not provide this kind of valid token, that person should be unauthorized, hence not having access to any other resources within our application. Now that the authentication route is created successfully, we need to move on with the other route, the recipes route. All those endpoints that revolve around the recipes, like creating a new recipe or deleting a new recipes or search through those recipes based on certain filters. So let's start. Let's add a new route. App.use API recipe. It's going to have a function here. We're going to call it recipe routes. Just like the previous one, we need to create this recipe app. So I'm going to copy it and create a new file within the routes. Inside the route folder, I'm going to create this recipe routes.js. And I'm going to copy the majority of the lines written down on the auth route and then paste them here. You know that we need to have access to the express, we need to have the router. There will be new controllers, so I'm going to get rid of this sign up and login. They're not necessary here. We're going to start with the post request. We're going to create new recipes. So let's just define some new names accordingly. I'm going to remove the sign up here. It was from the previous section. Let's call this new one create recipe. So the controller's name is going to be create recipe. I just left the endpoint empty here so that once the user goes through API recipe without anything added there and just create that post request, it will go through this controller. Let's save it. Let's not forget to bring in the file. This needs to be imported inside the server. So just like the auth router, we're gonna port the recipe routes. It's gonna come from routes. It will be recipe routes. Save it. Now back to the recipe routes. This controller is not yet created, so we need to create it. I'm going to go ahead and add this create recipe controller inside the controller. So let's define a recipe controller. And within this JS file, we will define that recipe creator function. So we need to create this create recipe function. This is going to be an asynchronous function. Let's define a try catch block. Let's import it first. Before we write any logic, just going to import it automatically inside the recipe routes. Save it. The logic behind the create recipe controller is quite simple. It needs to get recipe information from the user, build an instance of a recipe schema, which is already created and imported into this controller function, save it, and then send it as a response. So we need to first create the recipe schema, the way the recipe information should be organized and the way that its properties are supposed to be structured. So this is an example of the recipe schema. We need to have a bunch of recipes as a JSON file with properties like title, ingredients, instruction, tags, author or the creator, ratings, and comments. I'm going to give you an example of how it should look like. For title, there is the string type. Ingredients will have an array of strings. Instruction will be a string. Author will be a reference to the user's schema. However, we need to have access to the object ID or that unique number associated with the users. For tags, we'll have an array of strings. As you can see, ID and version are automatically added by MongoDB. And for ratings and comments, we'll still have an array. We'll eventually create a different controller to enable other users to rate recipes. So these ratings will be populated by users. That will be the same thing for comments. Users will be able to comment on every single recipe. I'm going to create a new model and call it recipe. Just like the user recipe, we need to have access to the mongoose, define a new schema, and add those properties and define the type. So I'm going to go ahead and paste the code that I have already created and explain what every single line does. Mongoose is already ported here. We have defined a new schema, got the title. The title should have type string, and it is required. For ingredients, it's supposed to be a string of array, and it is also required. For instruction, just like the title, the type is defined as string, and it is also required. The author property makes a reference to the user schema, and it just looks for the object ID. As you remember from the previous slide, it is going to be a mix of alphanumeric values. Tags would refer to an array of strings, and we'll have the ratings, which is an array of objects. For every single object, we will have property user referring to the object ID of the user schema, plus a number signed as a rating. We'll have the same logic for the comments. We will have an object array, and inside every single object, we'll have access to the user and the comments. The comments would be a string, just like something the user enters, and this would summarizes the whole structure of the recipe schema. Let's save it and get back to the controller. We're going to get the title, ingredients, instructions, and tags from the user. The all will come from the body of the request sent by the user. Now it's time to create an instance of the recipe. This is going to come from the recipe schema from the models. And let's include everything. Let's save it. And send it the status code 201, indicating that something has been recently created, and send this recipe as the JSON, the response. And if something breaks down along the way, we need to activate the catch error block. It's going to respond with a status code 500, referring to something being broken down on the server side. And this is going to have an indicative message, something that tells us about the kind of error. MongoDB failed to create a recipe. Save it. You might wonder why the author hasn't been added to the body of the request and the recipe does not include body. Or in other words, every person would be authorized to go through the API recipe, make a post request, and create this recipe, which is a correct assumption. And of course, this is not a safe way to create APIs. And that's why middleware come into play. We need to create a middleware that authenticate user. In other words, only those users who have recently logged in will be able to create recipes. The other users will run into an error, or they will see something like you are not allowed or you are not authenticated. So we need to implement this kind of middleware to authenticate user and allow them to gracefully enter their information like title, ingredients, instruction, and tags. So let's add a new folder and call it middleware. Inside the middleware, we're going to define auth middleware. In the context of Express.js middleware, the next function plays a crucial role in controlling the flow of request handling. The primary purpose of next is to pass control to the next middleware function or the next route handler. If you call next, it tells Express that the current middleware has completed its task and it should proceed to the next middleware or route handler. In other words, if it doesn't complete its task, it kind of stops it from going to the next middleware or the next route handler. And in this specific scenario, we're going to implement a mechanisms that define whether the user has been authorized, in other words, has got the token or not. If the user has got the token, the next function would forward these users to the next router. So it will successfully go through the create recipe controller. In other words, if the user is not authenticated, hence not having the token, there should be some sort of prevention mechanism to stop him or her from going forward. This is how the middleware comes into play. And I'm going to explain more further down the road. So once a user tries to use this URL, they will be proceeded to the recipe routes. Inside the recipe routes, we need to import this auth middleware. So I'm going to save it first. And export it. User goes through the recipe apps. So before being authenticated or before being prevented from using this controller, the middleware should come into play. So I'm going to import it. It is automatically imported here, and the middleware is placed between the URL and the controller here. I'm going to save it. Inside the middleware function, I'm going to do a console log on the request so you can see what kind of information are included inside the request. So this is the request from the middleware. Save it, run the server, and go through this route. Let's open Postman. Save the previous one. We're going to add a new request here. This is going to be post request. I'm going to copy URL here. Let's create post request without any particular body. So we are inside this URL. We're using a post request. I'm going to send it. And let's take a look at what we have logged inside the terminal. So this is a very large data coming from the middleware. So yep, look at this request from the middleware, and this is such a large value. So this is what we can get from the request of this endpoint. I logged this very large value to show you that it is possible to have access to some of its properties. Later on, we're going to put the token inside the header, which is one of the keys of this request, and then forward it to the next handler, which is the recipe controller. So the request flow would be something like this. The user make a request to API recipe, goes through the auth middleware. Inside the auth middleware will have access to the token, and then using the next, that token will be forwarded to the controller. So the token will come from the auth middleware and will be forwarded to the create recipe controller, and then it decides to whether authenticate the user or not. I'm going to make another request to the same URL, but this time, instead of this very large request data, I'm going to have access to the headers key. And inside the headers, I'm going to embed the token or some sort of value from the Postman. So let's open the Postman, go through the same post request URL. I'm going to load the part with a bearer token. Let's just put a random value, something like this. I'm gonna run the server. Okay, the server is running. Let's make this post request. Back to the server, and here we go. We've got access to the request from the middleware, but this time it's just the headers. The headers contains the authorization, bearer, this random value, and this is going to be a real token. And this real token will be created when a user logs into our system. Okay, we're going to need to have access to the authorization. I'm going to copy this authorization value. Then if it exists, I need to split it based on spaces. And then we're going to look for the second value, because the second value is the token and the first value is the bearer. Save it. Let's run the server again. And do the same thing. Choosing authorization, bearer token, and the same URL. I'm going to make a post request. And as you can see, this time we are exactly having access to the token. So let me just get rid of this console log and instead define real token. What if someone is trying to have access to our resources, doesn't have access to any token, and has not provided any token? So in this scenario, if token doesn't exist, we need to send a status code 401 indicating that it doesn't exist with a JSON message telling token not provided. Assuming that the user does provide a token, we need to pass it along to the next handler, which is the controller. So I'm going to define a try-catch block, and inside it, I'm going to define decoded value. By decoded, I mean that weird token will be decoded and will have human readable value, which is going to be the ID of the user. To decode this token, we need to use the verify method from the JWT. So we're going to use the verify method out of JSON Web Token. JSON Web Token also needs to be imported. So the verify method gets two parameters. The first one is the token created here, and the JSON key, or that secret key, which needs to be compared against the value coming from the token. So let's get it from the environment variables. Head back to the .env file and copy JWT secret right there. So to test this out, let's just log the decoded value here and see what it exactly shows us. So this is going to be the decoded value. I'm going to head back to Postman. Let's rerun the server again. I'm going to log in. Okay, a new token is created. So I'm using this endpoint API auth login. And I just renamed it to login. Previously, it was new request. You can feel free to rename it to any other value. Server is running. I also did change this one, API recipe, and it's got a new name, auth middleware. Now that we have created this token from the logging post request, I'm going to copy this value and go through the middleware and provide a bearer token with the real token and make this post request. So take a look at this. We have access to the decoded value. The decoded value has got three values here: the ID, the timestamp that it was created, and the expiration time. So let's turn these epoch values into a human readable date so we can see exactly the difference between the creation time and the expiration time. So I'm going to copy this value and head back to this website, epochconverter.com. Let me just paste that value, and yep, here we go. So it's December 31st, and yeah, this time. Now, I'm going to compare it against the expiration time. So normally it's supposed to be 1 hour later than that. Because you remember in the option part of the login, we decided to add the 1 hour expiration. So I'm going to paste the new value. And look at this. 339 turned into 439, meaning that in 1 hour, this token will be expired. And by the way, Happy New Year. So what would happen if someone provides an expired token or a wrong token? So let me just create and complete the error part of this try catch. Okay, the status code 401. Okay, let's save it and head back to Postman. Let me cancel the previous one. And of course, I need to rerun the server. You can feel free to install packages like NodeMon to rerun them automatically. Okay, now I'm gonna slightly change this token. Okay, I'm gonna change the last character from 8 to 9. Send it again. Look at this, wrong token. So it didn't go through. Let me just revise the message here. Unauthorized would be better term from a security standpoint. I'm going to rerun the server and let's just get back to Postman. Okay, what if someone doesn't even provide a token? I'm going to delete this and make another request. So you can see that the token is not provided. So the proper message is shown here. Okay, assuming that the user is authorized and correct token has been decoded. Now we need to find the user by that ID and then send it to the next handler. So I'm going to attribute a new value, user, to the request, and I'm about to use the user schema. And try to find it by the ID. And with the next function, we're going to forward this value to the next handler, which is going to be the create recipe controller. So later on, we'll have access to that user request.user from this auth middleware, and it will be handled here. Let's not forget that user schema needs to be imported from the models. So I'm going to go ahead and define it. Models and user. Now, let's head back to the controller, create recipe. We need to add another thing to complete the body of the recipe. I would like to draw your attention to the recipe model first. Inside the recipe model, we had a few keys that were required and they needed to be provided in order to make this recipe instance. For example, title was required, ingredient, instruction, and there was this author. And we didn't really provide the author in the controller. So it was not provided from the request body. And this is exactly where the authenticated user will be provided through the middleware. So I'm going to go ahead and define the author as request.user. Let's take a look at the recipe again. The author is supposed to be an object ID, so it's not a name, but that object ID refers to the user schema. So I'm gonna use the term ID and go from there. Just going to double check what this author brings us. So let me just do a console log here. Author. I'm gonna write author here. Okay, so the next is supposed to bring us the request user, and it's going to be handled to the controller. I'm going to save it and rerun it. Let's head back to Postman. I'm going to use the login URL. Let's make a post request and get a new token. Okay, you're highly recommended to get a new token. There's a high chance the previous one is already expired. I'm going to copy this and go to this URL, recipe, API recipe, to create a new recipe. Let me just rename this auth middleware because the previous explanation was mostly revolving around the authentication concepts. So I'm going to write a proper body. I have already copied an object for the body. It's got the title, ingredients, instruction, and tags. And as you can see, the data structure matches with the schema of the recipe. Got the string for title, string array for ingredients, string for instruction, and string array for the tags. Okay, I'm going to populate the token part. Here, make sure to click on the authorization and from various methods, choose bearer token and paste the most recent token. Okay, let me just copy it properly. We don't need to have the term token itself. Paste it here. Okay, as you can see, a new object has been created. It's got the title, ingredients, instruction, tags, and the ID. As you can see, the ratings and comments are also added automatically as they were already part of the recipe schema. So in the recipe schema, we had comments and ratings. So because they were not provided on the body, they are automatically added to the result. We have the ratings and comments as empty strings. If you notice, the only key that has not been attached to this value was the author. The author tries to make a reference to the user schema. In the controller, the recipe controller, we consoled the author, and the author was the result of user being attached to the request from the authentication part, and it was forwarded using next. On the terminal here, you can see that there are a bunch of keys that match very well with the user schema, as it was referring to the user schema. All we have to do is to get the object ID of this author and add that object ID to this instance of the recipe schema. So once we add the author, it will refer to the object ID of the user. So it will be something like this value here on the terminal. Okay, I'm going to go ahead and use this one. And only refer to the ID. We don't need the whole author object. And I'm going to copy this and add it here. Now, there are 5 keys added to the recipe instance. I'm going to remove this. We don't need this console. Let me save it. Now we have all we need to create a complete recipe instance. But before making another request and creating another repetitive value, let me just open the MongoDB Compass and delete the previous value because author was not added there, and we definitely need to have the author as part of the recipe instance. Okay, I'm gonna maximize it. Let's bring it here. Let's connect. Previously, you might remember that only we had the users, but right now the recipe has been added as well. Okay. I'm going to delete everything here. And I'm going to head back to the Postman. We're going to create another recipe or a new recipe. I'm not going to add anything regarding the author because the author is supposedly authorized and it's going to go through the middleware. Everything is ready. Let's restart the server. And I'm going to run it. Okay, and as you can see, the author has been added here. I'm going to open the MongoDB Compass, and yep, here we are. We've got the author added to this object. We've got everything, a new recipe has been created, and the type of every single key here match very well with the schema of the recipe. Now let's create another route for the recipe. Now we're going to enable our users to be able to search for certain recipes. This is going to be a GET request. We're going to add search. We would expect our users to be authenticated, so let's put the middleware here. And let's create a new controller and call it search controller. Save this. We're going to create this function inside the recipe controller. This is also going to be an asynchronous function, getting the request and the response. Using query strings, we will define keyword, ingredients, and tags, and the user will add some values to these three keys, and based on these queries, the recipes would be searched and filtered. So we'll have keywords, ingredients, and tags. And they all are supposed to come from query strings or the query part of the request. There will be three searching criteria included in our application. First of all, we're gonna do a case-insensitive search on titles. So regardless of the capitalized format of your words, you will get some results. The second criterion would be all ingredients included in the query. For example, if you add tomato and potato, it just looks for recipes that includes both of them, not just one of them. And the third one would be selection of either of those tags. So as long as there is at least one of those values included in the tags, for example, only tomato or only potato or both of them, that would bring you a result. Let's start with the case-insensitive values on the titles of those recipes. First of all, we need to define a query object. And this query object is supposed to be populated using those three values: keyword, ingredients, and tags. Assuming that keyword exists, we will populate it with title, and this title will do a regular expression search, which comes from the MongoDB. I'm going to write it down and give you the reference to how it works and explain what it actually does. If you go to this website, MongoDB, regular expression, you can have abundant information about how to set regular expression. Regular expression are simply some patterns that help us filter large data. For instance, we have specifically used this structure. The pattern is replaced by keyword and the option is replaced by I, which refers to case insensitivity. So it doesn't matter if we use an uppercase letter or a lowercase letter, it just understands the pattern and looks for either case. Let's run the server and define a query. I'm just going to show you how this query.title is supposed to be populated here. I'm going to save this. Okay, there is an issue here. So search controller has not been imported. So back to the recipe routes. We need to import the controller. I just removed the last two letters and put them again, hoping that it gets us the automatic importing. So it's automatically imported. I'm going to save it. Run the server. I'm going to head back to Postman, go through this URL, API recipe, and search. So let's create a new request here. It's going to be a GET request. API recipe, search. Okay, let's make this request. Okay, token not provided. We need to provide a token. Let me just take a look at the server. So it seems that something has broken down the server. Let's see what it actually is. Okay, it's got something to do with the headers, and we set the headers inside the auth middleware. So basically, it's just trying to have access to it, but since there is no token, it is not attributed to it. So we need to do this return here to make sure that the rest of the code will not be triggered if we run into this if statement. So by adding this return, the rest will be dismissed. Let me just save this, rerun the server, and head back to this. We need to log in again. Okay, a new token is created. Let's copy this. And provide it here. Okay. Now we need to create some queries. Remember, the key was keyword, and the value can be anything. So I'm going to write down the term beef, as if you remember, there was one recipe with the term beef in its title. I'm going to send it. And back to the terminal, you can see that the query has been created here, and the key title has been attached to this query. It's got the regular expression, and it's ready to be implemented inside the recipe instance. So the next thing that I'm going to do is to create a recipe instance. It's supposed to do this query, tries to find the query from the schema. So I need to import the recipe. I've already done that. Can go ahead and bring it on from the models. Okay. I'm going to do a console here and name it as recipe. Let's see what this recipe is based on that query. Okay, to the Postman. We are on the right URL. The keyword has been added. I'm gonna capitalize the whole word here. Let's make this request. And take a look at the server. We've got an array of objects, but there's only one object in it, the one with the title beef. And as you can see, it is all written down with the lowercase letters, but since we define this kind of regular expression to ignore the sensitivity of the cases, it is just bringing us this value. Now, let's just change this. I'm going to add something like sauce as well. So it is now trying to look for any recipe that includes the whole term beef sauce. It's not looking for only one term, but both of them together and with this kind of order. Let's make this request and see what it does. So you can see that there is no value added to this array, meaning that there is no recipe with this specific title. Let me cancel this. Now let's include this word. We know from the previous search that there is a recipe with roast beef in it. Now 2 words have been included. Let's make this and see that again we've got this. If I swap the place of these 2 values, it is not going to bring us any output because there is no recipe with this title in it. So it's an empty array. Let's add the second filter here. Assuming that ingredients exist, we will look for values that include all of those searching criteria. For example, if tomato and potato are included, we're looking for results including both of them. Let's have a closer look at the MongoDB documentation where some information about the all operator is laid out here. According to MongoDB, the all operator selects the documents where the value of a field is an array that contains all these specific. In simpler terms, we can add any term for ingredients. It can have onion, spice, or whatever word that you put there. As long as all of them are included in a document, you will have an output. So let me just delete everything from here and rerun the server. I already added this console log here. Just want to see what kind of query is being made. And I would like to add this instance of the recipe schema and a console log for the recipe. Let me save it, rerun it. Back to Postman. I'm going to go ahead and input the ingredients. And let's just add the term lemon, for instance. I'm going to make this GET request. Okay, so this is the query. No keyword has been provided. We have only access to the ingredients, and it's got this kind of searching criteria. However, for the recipe, you can see that there is an empty array indicating that there is no recipe with the term lemon in it. So let me just stop this and add onion. Okay, look at this. With this new query, we have this object. Inside the ingredients, we have the onion. So as long as that term is included, we can have this kind of result. Now I'm going to go ahead and include another word which is not part of this ingredients. So onion will be there. Let's write garlic. And look, even though garlic is included, there is no value here because there is no ingredients having all of those searching criteria here. On the other hand, if I include something that is already part of the ingredients, let's say fat, which was already there, we can see this new query and, of course, that object. You can go ahead and create lots of recipes with various words, terminologies, and titles, and to see how it interacts with your commands. But generally, the all operator gives us this kind of flexibility to filter based on a holistic set of values, not just one value. Let's add the third search. It's going to be about tags. If there is a tag, we would like to populate the query with tags. This time, we're going to use a different operator. It's going to be in from MongoDB, and it's supposed to split it just like the ingredients and turn it into an array of words. I'm going to now draw your attention to operator in. According to MongoDB documentation, the in operator selects the documents where the value of a field equals any value in the specified array. For example, if you have an array of 3 or 4 words, as long as only one of them exists, either of them, it doesn't matter, as long as either of them exists in your search, it will output that value. So I'm going to rerun the server and make a new query. In this new query, I would like to attribute tags with a few words. You remember, inside our database, we had a particular recipe with 3 ingredients and 2 tags, Italian and carnivore. We're going to have tags. Let's include French and vegetarian. You know, none of them exist. I'm going to make this request. And as you can see, this is the query, but there is no value for it. Now, let me cancel this. I would like to add one of those values that was already part of the tags. Italian. So we have 3 values, an array of 3 words. Only one of them is part of our searching criteria, and that would be enough to have some result. And you can see the new query has got 3 words. 2 of them are not relevant. French and vegetarian are not part of our tags, but there's this Italian word, so we have some data here. So let me just create a few more recipe, change some of those words, and make better searches here. For example, instead of roast beef, let's say chicken. American and carnivore. Okay, I am not authorized. Problem. Let me log in. Copy this token. Date the token in the bearer token. Send it again. Okay, now there is another value added to our database. Back to the search. Let me cancel this. I'm gonna go ahead and use carnivore here. Make this. Okay, it seems I'm not authorized. It's fine. New token is added here, updated. Okay, let's see the server. Okay, look at this. This is the new query. 4 words were included. 2 of them were totally irrelevant. There was this Italian and carnivore. So the term carnivore is part of the tags for the first ingredient, for the first recipe. And the term carnivore is also part of the second recipe. So there are 2 results and both of them are included. Okay, now that the search is completed, let's just improve this code. I'm going to remove this console. Instead, define a try-catch block. Okay, so we're gonna create this instance of the recipe schema. If there is a recipe, in other words, if that array is not empty, it's going to return this with a status code 200, meaning that it is successful, and we'll send this as a JSON and put the recipe there. Otherwise, if it is empty, then we will return 404, meaning that nothing was found. No result was. And inside the error block, we're going to return this server error with status code 500, referring to something related to server issues. JSON. I'm going to write an indicative message here referring to the search failed on the server. I'm gonna save it. Let me remove this one. Rerun the server and do a bunch of new searches. All those if statements are already created. One for keywords, which refers to the title, another for ingredients, tags, and once they are all completed, the query would be populated and it would be transferred to this instance. I'm going to open Postman. Okay, let's just do this. Okay, great. There is a result here. There are 2 values which have got the carnivore tags, the first one and the second one. Now, I'm gonna change this vocabulary, something totally irrelevant, and send this. Okay, there is the term Italian, that's why only one of them was found. Now I'm gonna change this. I'm gonna remove this. Doesn't matter. All three are irrelevant. So I would normally expect not to have any result. And yep, here we are. We've got the 404 error and no result was found. Let's create another route to get a particular recipe based on its ID. So we're looking for specific recipes. Let me copy this here, paste it. This is going to be looking for specific IDs, and I'm going to write it as get recipe. We need to create this. Okay, inside the controller, I'm going to add another function. We're going to use URL parameter to search for a particular recipe. And the ID here refers to that parameter. The parameter is supposed to be part of the recipe schema, and it's going to be its object ID. Let me open Postman. If you remember, every single recipe had its own ID. So this is going to be the value that would help us search for a particular recipe. So inside the controller, I'm going to define a try-catch block. We're going to have an instance of the recipe schema. Okay, recipe schema is already there. We're going to make it an asynchronous call. It's going to use its find by ID method, which finds by ID. And we're going to have access to the ID parameter, params ID, and we'll get this recipe. Recipe was not found. Then we need to return it with status code 404. Message like this. Recipe. On the other hand, if there is a recipe, it needs to return it with a status code 200, meaning it was successful. We will see it on our Postman or any other API testing platform. And for the error block, if something goes wrong, we're going to have a status code 500 referring to server error. Okay, let's restart the server and test it out. Postman. We're going to create a new request, but the previous one would be better to be renamed, so I'm going to rename it. Search based on filters. Save it. Let's add request here. Okay, now there. This is also going to be get request. Instead of this search, we're going to have access to a particular ID. So from the previous endpoint, I'm going to copy one of those IDs, copy this, provide it here. Seems like there is an error here. So yeah, the router was not imported. Make sure to import the route early on. Get recipe was created, but the controller was not imported into the recipe routes. I'm going to rerun it. Back to Postman. We're going to use this URL parameter to look for this specific recipe. Okay, so yep, here we've got this one. And what if I enter a wrong value, something that does not exist? So I just changed it, and I'm going to make another GET request. Okay, so we've got a 404 error message is recipe not found. And yeah, we've got the server connected as well. What if someone is not authenticated? Let me just add a value here and totally change the token. So this person is unauthorized. Even if that person is authorized, but entering the wrong ID, they will not have access to the recipe. Okay, so roast chicken, I'm gonna check it on the other as well. I'm gonna use this value instead. So let's search for the other recipe. And yep, here we've got the other recipe. I'm gonna go ahead and rename this so it's more informative. Search by recipe ID, or search by a URL parameter, which in this case we call it an ID. It can be anything. I'm going to save it. The next router is supposed to be a delete request. So we're going to delete a particular recipe based on its ID. Let's call it delete recipe ID. Save it. Inside the controller, I'm going to define a new function. This is going to be a delete request. So make sure to do this change here. Inside the controller, first of all, we're going to have access to the ID entered in the URL by the user, and it's going to be part of the request parameters. Let's define a try catch error block here. Deleted recipe would be a new variable here. We're going to have access to it and then delete it. So we need to Once again, get access to the recipe schema and use this specific method. Find by ID and delete. Find by ID and delete. This will have access to the ID, which is defined already. Okay. If there wasn't a value, in other words, if the user enters a wrong ID, then nothing should be deleted. So it should return a 404 error. It does exist, then we know that the previous line, this line, had already deleted it. So all we have to do is to return it. This is going to be a successful message. So status code 200. And message is recipe deleted successfully. And in case anything regarding the server happened, we need to have a server related error. So this is going to be 500. Status code. Server error. Error. A message coming. This block. So this is more informative. Previously, I was not adding any message related to the catch block, but you can definitely feel free to do so. Okay, I'm going to save it. Okay, let's make sure that this is already imported in the routes. It is not, so I need to do it. Save this and rerun the server. Postman, let's create a request here. It's going to be a delete request. It is exactly the same as the previous request. So I'm just going through the same route. I have added a particular ID and I would expect this to be deleted. Let me change this for now. You know, this definitely does not exist, right? So let's see what happens. Okay, the token is provided. It's used to provide it from here, from the logging request. Once again, the ID does not exist. Okay, recipe not found. Okay, recipe deleted successfully. I'm going to make another request to see all the remaining recipes. Okay, we need to do the authorization. Okay, as you can see, there is only one recipe left here. Next route is supposed to be the rate recipe. Users will be able to rate recipes. So I go ahead and make a post request. Based on the ID, they will rate those recipes. Once again, this is going to be authenticated, so the auth middleware will be included as well. Let's call this rate recipe. Save it. Let's add this new function inside the controller. Save it. Just going to make sure that it's imported here. Okay, great. Imported automatically. Let's take a closer look at the recipe schema. In the recipe schema, there was this ratings, and the rating was an array of objects, and each object contained a user and the rating, which was a number. So at the end, every single ingredient is supposed to include a bunch of users entering their number and attributing a certain point to that certain recipe. Let's have a look at the recipe route. User is supposed to make a post request based on the object ID of the recipe that needs to be rated. So once he goes through this route and make that request, that number, which is going to be part of the body, will be attributed to that certain recipe. For example, a user may enter number 5 or number 4, and number 4 will be added to this. The rating for that certain recipe will include a new object having number 5 or number 4 or whatever number that the user attributes to that certain recipe. This is what we're going to do. First, we need to find that certain recipe, just like what we did previously. We will find it by URL parameter. Once found, we will push a certain number, 5, 4, whatever, a certain rating number to that recipe ratings array. So first of all, let's get the rating. The rating will come from the request body. Then we're gonna find the recipe by the ID. I'm gonna define a try catch block here. This is gonna be an instance of the recipe defined by D, and the ID will be part of the URL parameters. Again, if the recipe is not found, in other words, the user enters a wrong ID, then it should return with a status code 404. If it is found, then we would push this value, this rating, to the recipe is schema. So it's going to be pushed to the ratings. Okay, it's going to be an object. The object is comprised of two values, two keys, the user and the rating. The user comes from the authentication process. So it's going to be request user dot ID. Once again, we don't want to have the whole user object, just the object ID. And of course, the rating, which is a number. Once the recipe is updated with this rating, we need to save this. So we need to use the save method. Once saved, we need to return a successful message. With the status code 200, and we'll send the updated recipe. And if something goes wrong along the way, we can return it with this catch block. It's going to be server error. And we'll have access to the message from the error block. I'm going to save this. Okay, I had already created some recipes. Let's see all of them together. Okay, there are almost 3. Yeah, there are 3 recipes created here. I would like to populate the ratings of some of them. Let's just select this one, the lasagna. I'm going to copy this and create a new point. This is going to be another post request. I'm going to paste the ID of that lasagna and go through the rating. Just double check, just make sure that everything is based on the URL defined here. Okay, it's rate. We need to provide a rating, and that will come from the body. So got the body here. Say 4.5. Just going to use the token. Without the token, I will get the unauthorized error. Okay, to the body, send this. Okay, I need to rerun the server. Once again. Okay, so yeah, here's the result. Lasagna, which already had an empty array for the ratings, now have got new value. It's got the user rating, and this is automatically added by MongoDB. Now let's create the final route for the recipe. It's going to be the comments router, another post request dedicated to commenting on different recipes. I'm going to call this comment. Save this. Inside the recipe controller, we're going to define the last function. Save it and import it. Save it again. This new function is going to follow the same procedure as the previous one. We're going to have access to the comments from the body, and then we're going to find the recipe and then push that comment to the comment section. So let's first get access to the comment, which comes from the request body. Once we get it, we need to define a try-catch block and try to have access to the ID. Okay, we're going to have access to the ID coming from the URL parameter. And the term ID comes from this. So in case you're wondering if it's changeable, it is. It can be interchanged with any other value. As long as it is the same as the URL, you are good to go. Okay, let's say this recipe is not found. If this recipe is not found, then we need to send a status code 404 with a JSON message saying that recipe is not found. And in case the recipe is found, we would like to push some value into the comment section. Copy the comment from here, write down the found recipe, then push some value. So the values are supposed to be first the user and then the comments. Just like the previous one, the user is found through the process of authentication. So I'm going to copy this. And here comes the comments. This comment would come from the request body. Once the recipe is updated, we need to save it. So we will use the save function. And once it is saved, we can show it on the response. And in case something happens and server run into any sort of problem, we would send the same message here. status code 500, server error, and some message related to the error. I'm going to save this. Now let's create the request on the JSON. We're going to go through this. So I'm going to add another request. This is also going to be a post request. Prior to completing it, let me just rename the previous one and save it. Create a recipe. And it is a post request, not a GET request. Have the same situation here. Instead of the rate, we're going to use comments. Just like this. Let's rerun the server. Head back to Postman. This is going to be a new post request. The body is supposed to have comments. Let's say someone says, delicious. Send this. Token not provided. So let me just copy this token. Okay, so yep. New comment has been added to this object. Let's take a closer look into the other recipes as well. Okay, I'm gonna select another recipe. You can see the comment section of this roast chicken is empty. So we need to populate it. This time, instead of this, I'm going to replace it with the one related to the new recipe. Instead of delicious, I would say smelly, whatever. Okay, let's send it. Roast chicken, which previously had an empty array, now has got a new object. Now that the recipe routes are completed, let's just head back to the server and add the last series of routes. The third one and the last one is related to users and all people using our services. I'm going to call this users. Okay, I'm going to define user route just like the previous one. It's going to be imported from routes. This is going to be user routes. Let's create a user routes inside the routes folder. And the express. And add the router. And let's export it. The first endpoint that we're going to create in regards to the user is a function that can have access to all the user, something that can output all the users registered on our service. So I'm going to go ahead and create get request. Once the user goes through this route, API users all, a function called get all users would get all the users registered on our website. Save this. So first of all, we need to create a controller dedicated to users. So I'm going to go ahead and inside the controller define user controllers. Okay, let's define the first controller. I'm going to save this and import it into the router. I'm going to just remove the last two letters. And yep, we've got it automatically. I'm going to save it. Just double check it on the server and make sure that the user routes are already part of it. Doesn't look so. User routes is in red while the others are in yellow. So probably there is some sort of an issue here. User routes, okay, I need to import it automatically. I'm going to save it. Let's not forget to put the period sign here. Save it, and it's okay. So this one was missing. Let's create the get all user controller. We're going to define try catch block. We need to have access to the user's schema. It's going to find the user. The user schema will be found in the models. So I'm going to define it as this. Models, and inside the models, we have access to the user. Save this. Let's return it. And if something happens along the way, we will get a server-related error. I'm going to save this and rerun the server. Again, we're going to go through API users and all. This is going to be GET request. So let me define a new one, but before going through the new one, we just rename this. Let's create request. This is a GET request. API users Okay, so here's the deal. There was only one user saved in our database, and that user was provided here. I'm going to go ahead and create another user. So let me just change this. Instead of boy, I'm going to write down girl. The password is the same and is slightly different. Okay, user created successfully. Let's make this GET request again. Now we've got two users. As you can see, the value of the password is part of this. We don't want this to be included. Even though it's quite safe, that would be better not to include it as a sensitive information. So I'm going to go ahead and deselect the value of the password from the controller. User controller. Let's deselect. By deselect, you can use this term. MongoDB, you can easily deselect one key out of a big object. Save this. Rerun the server and do this again. Let's head back to the Postman. I'm going to make another request. This time, password is not included. In other words, by using -password inside this select method, we are actually deselecting the value from the object. Now let's create the second route. The second one is about to get user profile. Imagine you are a user and you're using this service and you would like to have access to your own profile. So you can simply make a GET request to your profile. We're going to use the authentication to have access to the profile. In other words, if you are not an authenticated user, you should not be able to have access to any sort of information. For that matter, I'm going to go ahead and import the auth middleware. Just copy this. And put it on all routes. Let's define it. It's gonna come from the middleware folder and got this. I'm gonna copy and paste it here as well. And now let's go ahead and create this user profile. It's gonna be a new function. Usual, we're gonna use a try-catch block. Try block, we're gonna make a request to the MongoDB, just trying to find where that user is coming from. So let's call it the user. It's going to be an instance of the user schema. And we're going to use the find by ID to look for that specific user. In case you're wondering how the ID is going to be retrieved, well, we assume the user is authenticated, so this is going to make our ID. I'm going to save this and put the ID here. It's not necessary to include the password, nor is it advised for the user to see the kind of hashed value there. So we're going to deselect it using the same method. And then return it with a status code 200. And in case something happens on the server, something breaks down, this is going to be caught using the catch block. Save it. It's time to test it on Postman. Let's run it first. Okay, something is broken down on the server. Okay, get user profile. It is not properly imported. Okay, let's save it. Rerun the server and get back to Postman. I'm going to rename the previous one and create a new request. This is going to be a GET request. And the GET request is selected by default. Okay, I'm going to make this. User is supposed to go through API users. I need to do a slide change here. It's on 5001. So always make sure to be on this on the right route. Okay, token is not provided. I just created a new token and I'm gonna populate it with a new token. Let's make the request again. Okay, and this is the user that is already authenticated. So let's just rename the previous request. Get user file. The next route that we're going to make is a put request. We're going to update information related to a user. So I'm going to go ahead and create a new route. I'm going to copy the previous one and paste it here. The only difference is that we're going to update something, so this is going to be a put request. Let's call the controller update user profile. I'm going to copy this and define a new controller. For the update user profile, we're going to have access to a user's email and their username. We can, of course, include the password as well and change the password accordingly. However, you need to make sure that bcrypt library is required to encrypt the value and create a hashed value for the password. We already covered it on the API auth, so I'm going to skip this and focus on the updating part. Values such as email and username will come from the body of the request. And we're going to use a method called find by ID and update. So this is the kind of method that we're going to update the user instance. So let's define the user as an instance of the user schema and use this method find by ID and update. So we're going to get the ID, which is the result of authentication. We also would like to get the new values for email and username. So these are the updated value coming directly from the request body. And there is a third parameter indicating that we're going to show the updated value, not the previous one. So we're gonna define this as new, and it is true. So this is part of the Mongoose documentation. Basically, it says if you found a new user, you don't need to show the old one. You need to respond with the new one. That's why we set the update to true. Now that this user has been found and updated, we need to return a response with status code 200. And it's going to be the user. Save it. Let's put everything inside a try-catch block. And define the error part. Server error. And an informative error message from the catch block. Save it, rerun the server, and get back to Postman. Same URL with a different request. So I'm going to create that one. Select the put request and paste this one. We're going to create a new body, but for that, let's see exactly who is authorized to do so. We're going to log in as this user, boy123. Okay, something is wrong. Okay, let me just check this out. Yeah, we didn't import this controller. Save it. Run the server, log in again, get the token, and go through the put request. Okay, boy123 is authorized, and we're going to copy this token, fill up the authorization part with the new token, and update the user. All we need to do is to enter the email and the new username. So instead of boy123, let's go with guy123. And the username would also be updated in this scenario. Once again, boy123 is going to be updated to a new value. Let's make this put request. Okay, yep. Inside the body, we've got this. The new username and the new email are here. And boy123 was updated. Just to make sure that the update has taken place, we'll make another request. And yep, the update has taken place here. Let's save this and move on with another controller. I'm going to rename it as date the user. And by saving it, will turn into a put request. If you take a closer look at the key here, followings, you can see that it's an empty array. So there are a bunch of keys here. The only one that is not populated with any value is the key related to followings. And the followings will contain values regarding the users. For example, some object IDs will be there showing who is following who. Let's move forward with creating the last router. We're going to create a post request helping user to follow other users. So this is going to be post request. Let's call this follow. And let's use the URL parameters and call it user ID. So once a user is making this post request, ending with a particular object ID of another user, that new user, the second person, will be added to the following list of the first user making this request. So I'm going to draw your attention to the user schema. Imagine you are the user using this service, right? You try to follow person A. Once you follow person A and you make that request to that person's object ID, person A object ID will be added to the followings key of your schema. So let's move forward with this and create it. Once again, we need to have authentication here, and let's call the controller follow the user. I'm going to save it and move forward with creation of a new controller. To create this function, we need to follow a few steps. First of all, we need to try to find the person we're trying to follow. Person A in this scenario has got an object ID. We try to find that object ID. If this person that we're supposed to follow does not exist, we will send a response saying that user is not found. If this person does exist, then we need to check whether this person is already part of our following. So is the user already following this person? If it does, no change is required to be, applied to the user's schema. But if this person is a new following, then we will add it to the following array. So let's go ahead and create it. The person we're trying to find is going to have an instance of the user schema, and we're going to use find by ID. And we're going to have access to the parameters coming from the URL, and this is going to be user ID selected exactly from here. Assuming that this person does not exist, we need to send a response saying, well, Wrong person, wrong user ID. Okay, this person is not found. Return this 404 error saying that the user is not found. Okay, let's assume this person does exist. Now we need to check whether this person is already part of the following list of the main user. The main user is going to be found using the same function. This person is already authenticated, so his ID is already part of the user body. Okay, if this user following does not include followee or user to be followed, then we need to push it. We are trying to make a reference to the object ID of the user, and you remember that those object IDs were coming with this underscore. So it does need to have this underline ID to be able to have access to the user to be followed. Okay, if this person is not already part of the following, please push it to the user's following. So I'm going to copy this, push it to the followings, and save the new user. The user with the new data structure and a new value. Okay, the user is updated with this new following, and now we need to send success message. Status code 200, and we'll see the new user. As best practices, we need to do everything inside try-catch block, be able to handle any particular error or any common server-related error gracefully. So I'm going to copy the whole thing here and put it inside a try. Here comes a server-related error. Save it. Let's rerun the server and run a test. We're going to go through this route and follow a particular person. So I'm going to open Postman. Let's log in first. Okay, a new token is created. And let's create this new request. Post request. And we're going to go through this route, API users, follow user ID. And for the user ID, let's see how many users we've got here. Okay, we are this person, guy123, and we would like to follow person B, girl123. Just provided the object ID, and let's make this post request. Once again, we need to have access to the token because all these routes are already authenticated. Requires authentication, so let's fill it up. Okay, so this is bringing us our own user instance coming from the user schema. Username is guy123, and a new following have been added to the followings array. So what if this person does not exist, right? What if a wrong ID is provided? So instead of this, let's say a wrong one. Okay, user not found. So what if it's repetitive and it's already part of the followings? Okay, we've got the same thing here. And now, if you get all the users, we need to have an updated user followings here. This needs to be updated. And we can see person A is following someone, but person B is not following anyone. In summary, we created a bunch of endpoints ranging from GET request all the way to POST and PUT request. First of all, we created endpoints to sign user up, log them in, making them able to create recipes, and based on some searching criteria, we applied some filters. Other than that, there was this delete request here, deleting the recipes. You can feel free to go ahead and create more endpoints, like adding more delete requests to delete users or adding more put requests to update certain criteria. It totally depends on your choice and your business. Other than that, you'll learn how to use JSON Web Token to create auth middlewares and protect your routes. And this concludes our first backend development tutorial. If you found it useful, please like the video and subscribe to my channel. It would help the channel a ton. Once again, I'm committed to creating more comprehensive videos for both backend and front-end development, so I would be more than happy to see you on the next one.